In the previous session, we saw Rolle's theorem. Now let's look at Lagrange theorem. Again, this theorem also is a mean value theorem which tells us something about a point in between two other points. Okay, let's look at the theorem. If a function f of x is continuous in a closed interval a comma b and is differentiable in the open interval a comma b, then there exists at least one value of c belonging to a comma b such that f of b minus f of a by b minus a is equal to f prime of c. Okay, again, now if we look at it graphically, what it means is that if you have a graph like this, and let's say this is a and this is b, if you look at this chord, what this theorem says is that if this curve is continuous between a and b, if it is differentiable between a and b, so you have a point c for which f of c is a tangent, or in other words, there exists a c belonging to a comma b such that a tangent at c, which is nothing but f prime of c, is parallel to the chord. Let's say this is a and this is b. Now let's see how to apply this. So let's say f of x is equal to x minus 1, x minus 2, x minus 3 in the closed interval 0, 4. Let's simplify this. X minus 1, let it be as it is, so x square minus 5x plus 6. Now x cube minus 5x square plus 6x minus x square plus 5x minus 6, x cube minus 6x square plus 11x minus 6. Now this being a polynomial implies that it is a continuous function in 0, 4. It is in real number, but we are being specific to this interval. Now f prime of x would be what? 3x square minus 6, 12x plus 11. So it is differentiable, it is continuous. So that means by Lagrange theorem, f prime of c is equal to f of 4 minus f of 0 by 4 minus 0 is going to be the slope at a point which is parallel to the chord or the line connecting these four, f of 4 and f of 0. So where c is belongs to 0, 4. Okay, let's do the substitution. We have x cube minus 6x square, x cube minus 6x square plus 11x minus 6. Now 4 16, 4 64 minus 4 16 6 96 plus 11 4s 44 minus 6, 64 minus 108 minus 102, which is 6. Now when we put x equal to 0, we are left with minus 6. So minus 6 by 4, which is 12 by 4, which is 3. Now we know f prime of c or f prime of x is equal to 3x square minus 12x plus 11, and now we know that it is equal to 3, right? So let's okay, now let's substitute it with this point c. So 3c square minus 12c plus 11, and we know at this point, that is at c, it is 3, right? So now let's solve this quadratic. 3c square minus 12c plus 11 minus 3, 8 equal to 0. Okay, let's directly apply the quadratic formula. C is equal to minus b plus or minus b square minus 4ac, 4 times 3, 12, 12 8s are 96, divided by 2a, so 6. 12 plus or minus 144 minus 96, 144 96, 14 minus 6 8, 13 minus 9 is 4. Okay, so square root of 48 by 6. Okay, so now 16 3s are 48, so this becomes 4 root 3 by 6. Okay, let's split it up. So 12 by 6 plus or minus 4 by 6 root 3. 2 plus or minus 2 2s, 2 3s. 2 root 3 by 3. Okay, so which means that there are 2 points in between A and B. Yes, where the slope is parallel to the chord formed by connecting what? Connecting A comma f of A and B comma f of B. Okay, so what this means is that you have a graph which goes something like this. I am just roughly drawing it, not strictly based on the function, but just to give you an idea. So you have a point A and you have a point B, right? This is A, this is B, and when you draw this chord, you have a line which is a tangent at this point and at this point. They both are parallel to the chord. Yes, so we have seen one application of Lagrange mean value theorem. Now let's look at the second problem. Now, if x is greater than 0 such that x by 1 plus x is less than log of 1 plus x, which is in turn less than x. So in other words, if x is greater than 0, we have to show that the log of 1 plus x is between x by 1 plus x and x. Okay, so f of x is what? Log. We are taking this part now. So let's say f of x is log of 1 plus x. We take this to the other side, so which means minus x by 1 plus x. Let's differentiate this. This becomes 1 by 1 plus x minus quotient rule, 1 plus x as it is times 1 minus differentiate 1 plus x, so x as it is and 1 plus x square. 1 plus x square, 1 plus x minus 1 plus x minus x. These two get cancelled. And let's see, 1 plus x minus 1 by 1 plus x square. These two also get cancelled. So we have x by 1 plus x square. Now this is f prime of x. And we know this is greater than 0. Why? Since x is greater than 0, we have given. Okay. Now This implies f of x is strictly increasing in 0 to infinity. How? Because the slope is greater than 0 for all values of x greater than 0. Since the slope is decreasing as x increases, because as x increases, this 1 plus x square keeps increasing. So which means this fraction keeps decreasing. So which means the slope keeps decreasing. So the graph would go something like this, right? So which implies in turn that f of x is greater than f of 0 for x greater than 0. Now this implies, now let's look at f of x. F of x is what? Log of 1 plus x minus x by 1 plus x is greater than f of 0. That means log of 1 plus 0 minus 0 by 1 plus 0, right? So log of 1 plus x minus x by 1 plus x is greater than log of 1. Log of 1 is 0. So that means this is greater than 0. Which implies log of 1 plus x is greater than x by 1 plus x. Or we can say x by 1 plus x is less than log of 1 plus x. That is the first part. The second part is, remember, we took this part. So this is our first part. Now the second part is we take this side. Log of 1 plus x. So let's say g of x is equal to x minus log of 1 plus x. Let's differentiate it. G prime of x is equal to 1 minus 1 by 1 plus x is equal to 1 plus x minus 1 by 1 plus x, which is equal to x by 1 plus x. Now here we know that this is going to be greater than 0 for all x greater than 0, and this is our condition. So if it is 1, 1 by 1 plus 1, 2, 2, 2 by 3. So it will always be greater than 0. Again, which implies that g of x is strictly increasing in the interval 0 to infinity. Yes. Again, why? Because the denominator keeps on increasing. Numerator also increases, but it is always slightly bigger. Okay. Which implies g of x is going to be greater than g of 0 for all values of x greater than 0. Which implies, let's bring back the function itself. X minus log of 1 plus x is greater than 0 minus log of 1 plus 0. Which implies x minus log of 1 plus x is greater than 0 minus log of 1. Log of 1 is again 0, is greater than 0, which implies that x is greater than log of 1 plus x, or log of 1 plus x is less than x. So we have proved both parts of the statement. So therefore x by 1 plus x is less than log of 1 plus x, which is in turn less than x. So as you can see, really great theorem. Okay, I think that's enough for today. Bye for now.